In this video, we're going to look at the significance of the vectors 1, 0 and 0, 1 when describing the geometric effect of a matrix as a transformation, and also their significance in finding a matrix when given a transformation. We call these vectors the base vectors. I is our usual 1, 0, and j is our usual 0, 1. Already marked on the diagram for you. You can see A at 1, 0 and B at 0, 1. I want to look at the effect that a matrix which is 3, 1, 1, 2, I want to look at the effect of this matrix on what happens as a transformation. Well, let's look at the points 1, 0, 0, 1, and also 1, 1, A, B, and C, and see their images. Well, if we multiply that together, we get 3, 1 times 1, 0. 3 times 1 is 3. 1 times 0. Take 3, 1 along to 0, 1. Gives me 1. And 3, 1 times the last column is going to give me 4. And just finishing this off, 1, 2 times the first gives me 1. 1, 2 times the second gives me 2. And 1, 2 times 1, 1 gives me 3. So we have our points A dashed, B dashed, and C dashed. Well, let's look at A for starters. A starts at 1, 0 and is then mapped onto 3, 1. So we can think of A dashed, didn't want that. Let's make that one tidier. A dashed is there. Now let's look at B. If we take B, we start at 0, 1, and B is mapped onto 1, 2. So let's draw a line to represent that from 0, 0 up to 1, 2, and there is B dashed. Now let's look at C. C starts at 1, 1, and the image of C is at 4, 3. 1, 2, 3, 4, 1, 2, 3. It's there, C dashed. And you can see now that we're actually forming a parallelogram. If I think of O, A, C, B starts as a square, O, A dashed, C dashed, B dashed ends up as a parallelogram. So let's just draw some lines to make that obvious. And we get one line there, another line there. And so the shape here, the square that we start with, becomes a parallelogram. What happens now if we look at the image of the next square along? Well, if we want the image of that, we want first of all to find out what happens to the point 2, 0. So let's look and see what happens if we have 2, 0. Whoops, don't want equals. On 2, 0. 3 times 2 is 6. 1 times 0 is 0. 1 times 2 is 2. 2 times 0 is 0. And so the point 2, 0 becomes the point 6, 2. The point 2, 0 becomes the point 6, 2. And the next point up, the point 2, 1. If I want to find the image of 2, 1, 3 times 2 plus 1 is 7. 1 times 2 plus 2 times 1 is 4. So that becomes 7, 4. So starting with the second square here, 0.21 becomes 7, 4. And now we can see another parallelogram appearing. Oh, hey, it didn't happen. Let's try again. That's better. So what we have now is if we take the first two squares of our grid, those two squares become two parallelograms next to each other. Well, let's move down a little bit. And here we can see what happens if I find the image of lots and lots of points. So that this square has been transformed onto that parallelogram as we had. The second square along has been transformed onto the second parallelogram. The third one onto the third, and so on. We've basically changed our square grid into a parallelogram grid. Well, let's look at the point 3, 2. If I want the image of the point 3, 2, that is 9 plus 2 is 11. 3 plus 4 is 7. So if we take the point 3, 2, let's call it D, then its image is at 11, which is nearly off the page, 7, which is there. There is E dashed. That is 11, 7. 10, 11 up to E dashed, back in, we're at 7. Well, D was 3, 2, which is 1, 2, 3 squares along and 2 squares up. The red A becomes the red A dashed. The purple B becomes the purple B dashed. And instead of going 3 along A, we can do 1, 2, 3 A dashed, and then go 2 B dashed, and we get up to E dashed. So we really have transformed our grid of squares onto a grid of parallelograms where we can use both of them the same way. On the square grid, my point was 3, 2. After transformation, it was 3, 2. Let's just look at another point and see that happening again. Let's suppose I take, ahoy, got a mind of its own. 3, 1, 1, 2, and let's start this time with the point -1, 2. 3 times -1 plus 2. 1 times -1 plus 2 times 2. So I'm starting with the point -1, 2. Look at it, -1, 2. And it's finishing on the point -1, 3. So before the transformation, we look at the square grid, -1, 2. After the transformation, we look at the parallelogram grid, -1, that's minus the red A, plus 2. -1 plus 1, 2. We could find the image of any point like this. If I want the image of the point 2, 7, all I have to do is switch to the other grid. 1, 2, 1, 2, 3, 4, 5, 6, 7. And wherever we've got to, we would have the image. Same thing is true if I start with -2, 5 on the rectangular grid, -2, 5. If I wanted to find out where the image was, I could go -1, -2, 1, 2, 3, 4, 5. So if we know what happens to the two base vectors, I, 1, 0, and j, 0, 1, then we know everything there is to know about the transformation.